Hi Year 12s, this is Mr. Lim here again, and this is a special request for this question from the 2020 WACE exam. This was a difficult question. It just really involved you really being able to interpret what the question was asking and extract the appropriate information. All right, so you can have a read of all of this. You hopefully have already read this. So let's just get started. A chemist used the above procedure to determine the percentage by mass of lanthanum, terbium and cerium in the fluorescent lights after completing step 1 and recovered 1.2 kilograms of the chemical coatings. Okay, so 1.2 kilograms is effectively all of this stuff here, right? And effectively all of that stuff there, right? At the completion of step 2, okay, so that's important, step 2, the mass of the mixture had decreased by 11.3 grams. Calculate the mass of sodium carbonate that had reacted with the rare earth metal phosphates. Okay, so mixture had decreased by 11.3 grams. The real question is, how in the world does this mixture reduce in mass? Because in theory, all chemical reactions should have consistent mass, and so you're not really losing any mass here. What's happening is that it's turning into something that can't be weighed. What can't be weighed? Gases can't be weighed. So effectively what this is saying is that, okay, it's lost some mass. Where did it lose that mass? It's lost that mass in any gases formed in the process. All right, so these carbon dioxides are where the mass loss has occurred. All right, what you'll notice is that each of these carbon dioxides, I wanted that. Yeah, why not? Each of these carbon dioxides shares the same coefficient with that sodium carbonate that produced it. So effectively, what you can say is that you can first of all work out the number of moles of carbon dioxide formed from this 11.3 grams of carbon dioxide, which will equal to something like, 0.257 moles. All right, and then that number of moles there effectively is the number of moles of the sodium carbonate, because all three of them have effectively the same coefficient ratio, so therefore you can work out the number of moles of sodium carbonate, and then you can work out the mass of that sodium carbonate by taking that number of moles and multiplying it by its molar mass, which gets you 27.2 grams. Okay, so then we can move on. Let's have a look at this next part of the question. The mass of solid sent from step 3 to step 4 was 1.16 kilograms. Okay, so step 3 to step 4. The solid was then leached with 6 mole per liter HCl to solid to liquid ratio of 150 grams per liter. The analysis of the solution at the end of the leaching shows that it contained lanthanum, terbium, and cerium, with lanthanum concentration being that there. Calculate the percentage by mass of lanthanum in the fluorescent light coating chemicals, giving that the leaching efficiency for lanthanum was 86%. Okay, so there's a couple of pieces of information in here. So you have a 1.16 kilograms of the stuff. You've got 6 molar HCl at a 150 grams per liter ratio, and you've got a concentration, I didn't want that color. And you've got a concentration of lanthanum of that. All right, so first of all, you need to work out how much HCl was added to the thing. All right, so solid to liquid ratio, you've got 1.16 kilograms, and you're going to put in 150 for every 150 grams, you're going to put in 1 liter. All right, so every 150 grams, you can just work out 1.16 kilograms, which is equal to 1160 grams, and then divide that by 150 will be equal to the liters that you'll add in there. All right, so that value is 7.73. 7.73 liters. Okay, this is the liters of HCl that you've added in there. Okay, so using that volume of HCl, you can also then work out the number of moles of lanthanum, because you've got the concentration that it forms in moles per liter. All right, so because you've got that, then you can work out the number of moles of, and I should zoom in a bit, number of moles of La, which will be equal to Cv, which will be equal to 8.65 times 10 to the negative 3 times 7.73. Okay, so that will be the number of moles within that solution, and that value will be 0.069669 moles. Okay, once I have that, I have to work out the idea that this did not occur at 100% efficiency. It only worked out at 86% efficiency. So that's the number of moles that was extracted, right? How much could have been extracted if it was running at 100%. So in theory, I'm looking to get the higher value. So this is the actual, and I want to get the number of moles of lanthanum that I theoretically could have extracted. So I take that value, 0.0669, and then I times it by 100 over the percentage, which was 86, which will get me a value of 0.0778 mole. And then I take that, why aren't you moving? Here we go. And then I take that value and I work out the mass now of lanthanum, because now I have the number of moles, and I can work out the mass of lanthanum as the number of moles theoretically I could have gotten out of it times its molar mass, which happens to be this value, and then that is equal to that many grams. And say hello to my son. Okay, so now that I've gotten rid of him, now we can then remember that we are trying to get the what am I asking for? Calculate the percentage by mass of lanthanum in the fluorescent light coating, which is like the whole mixture of everything, right? That whole mixture of everything was all the way back here as 1.2 kilograms of coating chemicals. So therefore that 10.8 grams as, I don't want the number of moles, as the percentage of lanthanum will be equal to the 10.8 grams over the 1,200 grams that it started out as, and that will eventually get to 0.9%. All right, so those are the values there that you need to try and follow along. And then lastly, this part here, okay? And so this one here, even though it looks like it's all step 5, step 6, and rah, 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 this is actually just a limiting reagent question. So what you need to recognize is that you've got cerium with a concentration of that many moles per liter and a volume here, right? And you're reacting it with oxalic acid with that concentration and that volume, all right? So this one here that's the oxalic acid. Here's the cerium chloride, right? Yeah, that's right, cerium chloride, yep, okay. And so therefore, I'm just working out whether was this enough to precipitate all the cerium. It's effectively a limiting reagent question. So let's go through that. What do we do with limiting reagent questions? Work out the number of moles of both of them. So cerium 4 plus, right, is equal to Cv. So that'll be 0.146 times 0.424, which will be equal to 0.0619 mole, right? Once I have that, I can work out the number of moles of oxalic acid, which will be H2C2O4, which will be equal to 1.15 times 0.110, which will be equal to 0.127 mole. Okay, remember then I need to work out here is the number of moles of cerium that I need. Now let's do oxalic acid, because that's what the answer key has got. So this is how much I need. From that will be equal to the number of moles of cerium times the molar ratio, which happens to be a 2:1, which will be equal to 0.124 mole. So therefore, the number of moles of H2C2O4 I have is greater than the number of moles of H2C2O4 I need. And therefore, not the limiting reagent, and therefore sufficient amount. Right, so that's it, okay? Hopefully that helps, okay? It is just really all about reading it and trying to analyze what information is given to you and what you need to work out. Okay, have fun. You want to draw a froggy with Daddy?
Yeah.
Okay, come here.
Mommy!
Look, we draw one froggy. Oops, that's not working. We draw one froggy with Daddy. Look, a froggy. You want a happy face froggy or a sad face froggy?
Happy froggy.
What?
Happy froggy.
Happy froggy. No, this froggy is all the students who are studying and they are sad face. So sad face froggy. Say good luck, students. Say it.
Good luck, student.
Good boy. Bye-bye.